Hey everybody, this is Mr. Munson. We're in Unit G.6, Unit 6, Similar Figures. And so we're going to look at the very first concept here called G.6.1, Ratio and Proportions. Make sure that you have your student learning map out so you can kind of follow along with the concepts that we're going to be doing. Let's go ahead and get started. Okay, in this unit, not this necessarily this concept, but in this unit, we're going to be talking about similar figures. And so one of the ideas is if we looked at four figures such as these that are given, and I was asking, hey, which two are similar? I'm hoping very quickly you'd recognize that this one is definitely not one of the two that are similar, right? The other ones are triangles, okay? So we know that that's out. So we start looking to see what's similar about them. So this one has sides of 3, this has sides of 3, this has some sides of 10, right? Now this one over here has 3 sides that are 3. This is only known as 2. Now I could use Pythagorean Theorem to figure out what that missing side is. And after I do my work there, I'd find that h is equal to 3 square roots of 3, okay? And I'm sorry, that's a 2, square roots of 2. And so we need to have a little bit better understanding, a little bit better definition of what is similar when we're looking at figures. Okay, so here's 2 ideas that must be true for figures to be similar. All right, so here are my similar figure requirements. First, the corresponding angles have to be congruent. That means if there's a 90 in this triangle, there has to be a 90 in that triangle to match it, or that one. Okay, so now I see that 90, and I can certainly find this triangle's angles by simply using some logic from previous sections. I notice that this is a isosceles triangle. Actually, it's equilateral, and that means that across from it are congruent angles. So 180 divided by 30 is equal to 60 degrees. So each one of these has to be 60 degrees. There's no 90 there to be found. So this is what I know. These 2 figures are not similar. Now, since they have 2 rights in these 2, these have the potential of being similar. Now, the corresponding sides have to be proportional. Proportional means that I can write a ratio between corresponding sides, such as like 3 over 10. That's taking this side and writing it to its corresponding side. And then this 3 to this 10. Right? And proportional means that those sides ratios are going to be the same. Now let's check the other ones over here. Again, I could use Pythagorean Theorem, but I know, because I'm starting to see a pattern, that on an isosceles right triangle, when these 2 sides are the same and it's right, this side is always square root of 2 with the number here out in front of it. So can you guess what this one would be, knowing that pattern? Hopefully you see it's 10 square roots of 2. So now let's take the ratio between these last set and see if they're equal to the same. Okay, so now through a little bit of math, I know that the square roots of 2 cancel, and I have 3 over 10. So all the sides are proportional, and we'll discover that in a little bit more detail in a further section, but I just wanted to lay the groundwork for that. Take a look at these 3 pentagons. 2 of them are similar, and the other one's not. And so through a little bit of analysis, I'd start looking to see what I can see quickly to eliminate, similarities. So I can see this has a 90, this has a 90, and this one has a 90. So far so good. So remember, all the corresponding angles, or the corresponding angles, have to be congruent. So if I see in this one 111, I need to see 111 in the other ones. Okay, so far so good. Also, what's important is not just any old 111. That 111 is next door to the 90, and it could be on either side. It doesn't matter, but it has to be next door to the 90, and that's true here and true here. So far so good. So if I look to one side of that 111, I should see 103. So let's go here, and there's a problem. Okay, so that says 124, and that one says 103. So this one's kind of out of the running for that. Okay, I don't have any chance of those figures being similar. So let's continue checking. After the 103, next to it is 122. So this is 122. And then we have this missing angle. We certainly could find that missing angle by using the idea of that we learned in the last chapter. Let's call it x. Let's say x x plus 122 plus 103 plus 111 plus 90 has to equal 540, and that's calculated by the 180 n minus 2 kind of thing, right? Okay, and so this equation is going to be the same for this one as it is for this one, so that x has to be the same number. There's no way it could be a different number. All the other angles are the same. Okay, so we can conclude, not with full understanding, but suspicion, that these two shapes are similar because they have corresponding angles. Now, it's the second one, the corresponding sides are proportional, that we don't have enough information to determine that. So we'll just pause here and say, if I had to pick between two of these figures being similar, those would be the two I would pick. So this section really is about ratios and proportions, and so we're just going to look at these things. If you look at your student learning map, you can see one of the first concepts is I can reduce and compare ratios, right? So there are 32 students in the 7th period class, 22 of them are girls. First question is, what is the ratio of boys to girls? So we're going to write these ratios two different ways. One as a fraction like that, and another one using this symbology, right? And so you've done that in previous classes. So in order to answer this question, I'm going to have to stop and figure out how many boys there are. Now I know that there's 22 girls and that there's 32 people in the class. Put me on pause and see if you can figure out just how many people are boys. All right. So there's 10 boys to 22 girls. Now, we're never going to leave our fractions not reduced, so I'm going to reduce that to 5/11ths. Now, the same thing is going to happen over here. It's going to be boys to girls. If you happen to write this one as 22 like this, you need to remember to reduce it. Seems to be a common mistake when students write it in this form, they forget to reduce it. Not so much here. What is the ratio of girls to boys? Well, that's just asking me to flip the numbers, which we'll just write it as 11/5. And in this case, the order is going to be this way. Girls to the total number of students in class. Okay, so we take the total number of, or the girls over the total number. We'll just write that ratio. There's 22 girls and 32 kids total in the class. Let's reduce that ratio and make it 11/16. Written in this form allows me to write it as 11/16. Now, you need to understand, I'm going to encourage you to write this kind of like script over here that tells you, it's like a code. It tells you what's on top and what's on the bottom so that you can make sure that you're writing it in the same fashion. This is going to become really important when we're writing equations, that we write the left fraction to be equal to right fraction. We're going to need to make sure that on both sides we're putting the same stuff on top and the same stuff on the bottom. All right, last one. So suppose the ratio, let me just kind of scroll this up. Suppose the ratio of boys to girls. I'm just going to pause and write that down. When they give me information like that, I'm just going to write down. Classroom is the same ratio as those in the entire school. Well, I know the ratio of boys to girls in my classroom is 5/11. I just figured that out at the top. How many girls are at the school if we have 1,754 boys? So how many girls, right, in this whole school? So that's kind of an unknown. So I'm going to have to write an equation. And this is called a proportion. A proportion is a type of equation where you have a fraction equals a fraction. Now we have girls on the bottom and boys on the top. So girls is what I'm looking for, total number of girls. The boys are 1,754 total in the school. Boys on top over here, boys on top over here. And when we cross multiply, we get 5 times the grand total, right, of the girls over, or equals, and then 11 times that 1,750. Then I'll divide each side by 5. So the grand total of girls is 3,858.8. I'm hoping that you realize there's no way you're going to leave that as an answer. Let's go ahead and self-round that up without even being told, whoops, to 59. So there's approximately 3,859 girls in the school. All right, how about something like this? It says for a batch of cookies, it takes 4 cups of flour and 2 cups of sugar. If I'm making 5 batches of cookies, how much flour do I need? For each batch, it's 4 cups of flour, right? So I'm just going to write a ratio, the number of cups to the number of batches, right? So now I'm going to go ahead and put an equal sign and build my other side's equation. I'm looking for the cups of flour now, and how many I would use for a batch of 5. So I cross multiply and I find the amount of flour I need for a batch of 5 is 20 cups of flour. Okay. Now, I think that many of you would be able to calculate this in your head and figure it out kind of logically. But what I'm doing here is I'm trying to help you build equations and get familiar with that so that when it gets a little bit more tough, when it gets a little tougher, you can build these equations. Okay. So what I want you to do is go ahead and do one for sugars. All right. Go ahead and figure out what sugar is, the ratio or the amount of sugar, cups of sugar I need, but write the equation, cross multiply and solve. Put me on pause and come back and check your work. And there you have it. So now I'm going to give you a couple of problems where you have to cross multiply, a little bit more algebra intensive. So what I'm going to suggest you do is when you write these down, you draw these arrows. And you just simply systematically walk through. I use parentheses at first to kind of show what's going on. I'm going to take 7 and I'm going to multiply it times the quantity, 2x minus 13, and then 4 times 28. All right, don't forget to distribute this through. Come back and check your work. And there you have it. All right, try your hand at this one. Put it on pause and come back and check your work. And there's that one. All right, let's move on. All right, so here we are. We're given the ratio of the angles. You can see it here in the middle of the words here. The ratio between the angles is 3 to 2 to 5. So that's one of the advantages of having this kind of notation with the colons is that when we're comparing more than just 2 numbers, in this case 3 numbers, it would be hard to write that as a fraction, right? So what it's just saying is that I have some angles in some triangle, and whatever this is, if I multiply it times some secret number, right, and this one times some secret number, whatever, it'll inflate it to the actual numbers. That this ratio has been reduced from real size angles. Of course, 3, 2, and 5 can't be the angle measurements because they don't add up to 180. But they've been reduced down, some common factor, 10, 15, something's been pulled out to reduce them down to these smaller numbers. And now we're trying to inflate it and bring it back up to the real numbers. So what we do is you take those numbers and you just simply put x's in them, and then you write your triangle sum theorem. And this will allow you to find that factor. So simply put those numbers together and make it equal to 180. And I get x equals 18. Now be very careful because that's not the question. The question is find the angles. So now all you got to do is plug those numbers back in. And there you have the list of angles. Now I can tell this is a right triangle. Hey, notice that I put in commas between the answers here. Sometimes I see students put the semicolons there. That's not a list, that's a ratio. This is not a ratio that I'm looking for. I'm looking for the actual numbers for the angles. And so I just list them. And I don't forget to circle my answer. All right, here's here's another one that's just like it. Go ahead and see if you can do this one on your own. And there you have it. Don't forget to put your little degree mark in there because they're angles. Okay, well this is a similar problem, but instead of talking about the angles inside of a triangle, we're talking about the sides of the triangle. The sides are proportional, right? So they've been reduced down to these numbers of 3, 4, and 5. And I'm looking for the actual sides so that the perimeter, when I add up all the sides, it equals 240. Again, this is done very similarly, right? I'm just going to find what factor has been pulled out of all these bigger sides that has allowed it to be reduced down to that 3, 4, and 5. So I just add them together because that's how I do perimeter. Perimeter is the sum of all the sides. And then I'll just simply solve that equation. And there I have it. Now notice I do not have degrees there because I'm not talking about angles. You have to understand what you're working with. These are sides of a triangle, okay? So one side is 60, another side is 80. It's a pretty big triangle if it's in, let's say, feet. All right, let's move on to this one down here and see if you can do this one on your own. Actually, it looks like it's the same one, isn't it? So we'll move on. And there you have it. Here's your do it problems for G.6.1. Please make sure you put your name and your period and all this, a date and all that stuff. You're writing down the information, the license fee for a car. You're just writing it out and then you're putting the answer underneath it. Don't write all the problems down and then do the problems underneath it. Just do one problem at a time so that you can space it out on your paper properly. Hey, don't forget to answer the question that I have. Find the measure of the angles. Find the measure of the sides, okay? Finding x is not all the way there. All right, have a fantastic day, and we'll see you next class.